In order to do sequential circuit designs, we're going to need memory elements. Okay, so what is a memory element? A memory element is a circuit that allows you to store either a 0 or a 1. So if you think about how that would work, you would need to be able to set the memory element to a 1 and then remove that signal that does the setting so that it stays there, so that the 1 stays there. And then once you had a 1 in the memory element, you might want to clear it back down to a 0. And so you'd need a signal that would initiate that action, and you could reset the memory element and move it back down to a 0. Okay, so that's the basic concept behind a memory element, and I wanted to cover the overview of what we're going to do in this section on memory elements because there's a lot of detail here, and I want you to kind of track the big picture of how things are working. So the first thing we're going to talk about is a very basic memory element, and that's called an SR latch. All right, so SR latch, that's the starting point. It's bistable storage, meaning that when you hit the signals that are allowed, it will give you a stable output. Okay, it will go to one of two different stable states, either a 1 or a 0. That's what the bi part means in bistable. All right, and then the next step we're going to do is an intermediate step. It turns out you can build an S bar R bar latch out of cross-coupled NAND gates, and that's been the traditional history is to use NAND gates, and so that's an intermediate step that we use on the way to making what's called a data latch. Okay, so with the data latch, we remove the idea of set and reset. Instead, we think of it as data that we want to store at some kind of enabling signal time. So it casts that away from set and reset into a data latch. And then we're going to find out, wow, it'd be better if we didn't have it level dependent. It'd be better if it was clock edge dependent. So it only changed values on a clock edge and not anywhere within the regular stable state of a clock. So to make it clock edge dependent, we go to flip-flops, and flip-flops turn out to be our basic memory element for digital systems design. Okay, so that's the path. Let me rewind that again. We start with SR latch. We go to S bar R bar latch, which is the same kind of operation. You just use a different signal to initiate set and reset. And from there, we make a data latch, but the latch is imperfect, and so we'd like it to be edge dependent, and so we modify that circuit to get to the flip-flop. The flip-flop is the basic element that we use for the most part in digital system design.